Great. Hello and welcome to today's webinar on fourth generation district heating. My name is Emilia Pisani and I will be the moderator for the webinar. As such, I would like to give a warm welcome to the experts who have agreed to share some of their knowledge with us today. We are very honored to have you here and are looking forward to listening to your presentations. As you can see on the agenda, first Anna will set the stage by giving us a brief introduction to fourth generation district energy and how it differs from third generation district heating that most of us use today. Then Roberto will talk about some of the groundbreaking solutions that these future networks present, as well as Jonas, who will present some of the profound transformation that energy networks are undergoing with digitalization. Finally, to round it up, Kristian will show us how Copenhagen, one of the cities in the world with most developed district energy systems, is working toward a carbon neutral district energy system. So let's not waste any more time. Anna Boss is an energy research engineer at RISE, the Research Institute of Sweden. Some of you may recognize its old name, SB, which since 18 days ago became RISE. She has been working there for the past 10 years and works mainly with district heating research. So she's an expert in the field. We're also very, very lucky to have Anna as a partner in the Celsius project. She has been the one behind the construction and development of the Celsius toolbox. Anna, the floor is yours.
Thank you, Emilia. Yes, my name is Anna Boss, and as Emilia said, I work at RISE Research Institute of Sweden, which has recently been merged by 3 different research institutes in Sweden. Emilia invited me to present some ideas and introduce the fourth generation district heating. And what is this? But I wanted to start with the why question. When we talk about future energy systems, there are often some nice words coming up, like we want them to be energy efficient, want energy efficient buildings and systems, and we want more renewable energy in heating systems as well as electricity systems and other energy systems. Also, we want the systems to be robust and reliable, as well as cost effective, of course. And to do this, we aim for smart and more integrated energy systems. I put the word sustainable in the middle of this bubble. In my mind, this sums up what we really need for the future. And this is the background to more efficient district heating systems. So I wanted to start with some general properties that are applied in most district heating systems that we have in Europe today, the third generation district heating. Distribution is mainly done by pressurized hot water, mostly below 100 degrees, sometimes a little above 110, 120 degrees. The systems are in general centralized with one or a few production facilities, mainly supported by fossil fuels or biofuels or a combination of these that are used in boilers or combined heat and power. In many cases, there is also a smaller share of other renewable heat and waste heat, like connected major industrial facilities in the area, and in some cases also incineration of waste, mainly in larger district heating systems. And there is a large variation of the efficiency in these systems. Some are pretty efficient and some have large losses and using a lot of fossil fuels. To move towards more sustainability, we need to use resources in smarter ways. One way is to use energy sources that are locally available. Use waste heat from industries in the area is one good start, but we could also use waste heat from urban infrastructure. You can see here a picture from the subway system in London, from which waste heat is used in the district heating network as the subway system is cooled. Another example is using sewage water, the heat from sewage water, and recover this for the district heating in combination with heat pumps. And this is applied in two of the Celsius cities, Gothenburg and Cologne. Maybe in other of your cities also, but referring to the Celsius project cities that we are investigating as demonstrators. Also decentralized heating from solar heating in buildings could be applied in the network. And we should also go for a more integrated system with other energy supply, for example, combined heat and power, which makes the production more efficient in combination, using heat pumps for further optimization possibilities. With these more complex systems, optimization and communication, handling of data gets increasingly important. Jonas will talk more about this later, I suppose. And then for matching supply and demand in time, energy storage is very useful. On a theoretical level, waste heat could be used to supply all of the district heating because there is more waste heat available in Europe than what is needed to heat buildings. But obviously that is not possible in practice, and one reason is that the temperature level of the waste heat is often too low. So one solution to increase the use of waste heat is to decrease the temperature level in district heating systems and applying the so-called low temperature district heating concept. A lower temperature gives also further benefits. It gets higher efficiencies in combined heat and power. Also a higher share of electricity generation is possible, and higher performance in heat pumps and solar energy. We get reduced heat losses in the distribution network, and as the buildings are renovated and uses less heat, and we have new buildings that are very energy efficient, it gets more and more important not to lose most of the heat in the distribution network. It's better that it gets to the buildings, of course. And additionally, we get reduced stress in materials at lower temperatures. So there are cheaper materials available, such as plastic pipes that could be used in these cases. So how much could the temperature be reduced? We still need to fulfill the demand of the end users and buildings, which is primarily space heating and domestic hot water, possibly other services in some systems. For space heating, a fairly low temperature is enough in new buildings and after major renovations. Usually 30 to 40 degrees or even lower is enough if you apply efficient distribution systems like underfloor heating, for example. Although in older buildings you might need higher temperature because they are designed for this, which varies a lot between countries and cities. For domestic hot water, we need around 50 to 60 degrees Celsius usually. This differs also among requirements in different countries. Usually the limit is set by the fear of growth of Legionella bacteria. I could mention that we currently have an ongoing project which is investigating one type of technology to reduce the risk to produce safe hot water even at slightly lower temperatures by avoiding circulation and storage of hot water. Anyway, there is no unified level of low temperature district heating, but rather it's defined like temperatures at or just above the limit that is set by domestic hot water requirements. So that could mean about 60, 70 degrees. There are also other concepts like ultra low temperature district heating, but this requires additional heat sources to raise the temperature locally at the building level. Roberto will talk more about this. Also, when you have lower temperature systems, it gets increasingly important to have efficient systems in the building and efficient substations and efficient heat exchanger to reduce the difference between the primary side and the secondary side. When constructing a new network, it could be designed for low temperature, although taking into account the needs of older buildings. In existing networks, there are some other challenges. You cannot just switch from 90 degrees to 60 degrees from one day to the other because of old buildings with higher requirements, but also because of capacity, which is restricted by the dimension of the piping in the network and the temperature level. Although if there is energy renovation in buildings ongoing and you get lower demands, then this might not be such a tough limitation. You could also decrease the level when buildings use less heat. And for new areas with new buildings that are being connected to the network, they could be connected through a secondary district heating system, which is applied in some cases, where, for example, the return temperature maybe in combination with the supply could be used to supply this newer area with lower temperature requirements. Then you get many of the benefits from low temperature district heating in this area. And in the area with higher temperature demand, this could be gradually decreased over time if that is possible. Also, you may not need to keep the same level at all times, but to have a dynamic optimization of the temperature, keeping lower levels at low energy demands and raising the temperature periodically to when you expect peaks. Also, before peaks, it could be used to increase the storage capacity of the network. The diagram here is an example from Gothenburg. The 4 different curves you see there, they represent different seasons of the year. If you look at the upper curve, the blue one, it represents winter, and this shows the variation of temperature during an average day. So here you can see that the temperature is increased by a couple of degrees in the early morning in anticipation of peaks in the morning, which means that you may not need to start the peak boilers, or you can have a lower load in the morning. Then finally, I would like to get back a little to the idea of integration of energy systems. First, integration of nearby district heating systems in small or larger scale, depending on what you have from the beginning, gives more available heat sources and makes it possible to optimize the overall production. Another strategy is to connect heating more with cooling. Most obvious case is absorption cooling, where you can use waste heat in the summer when it's not demanded for heating and turn it into cooling that is more required during that period. Heat and electric power can be integrated in many different ways. Combined heat and power production, as I mentioned before, to increase the total efficiency and optimization opportunities. Also heat pumps, and ideally if you can choose to use combined heat and power or heat pumps depending on the prices and the demand of electricity and heating during time. Also, electricity could be stored when there is an excess of production. It could be stored as heating the district heating system, because when we use more renewable and intermittent electricity sources, there is sometimes an overproduction that need to be handled in some way, and then it could be used in the district heating system, preferably in a storage. Another technology that is fairly new is heat power technologies to produce electricity from heat to get back the electricity that has been stored before, or to use it when electricity prices are high. We have some ongoing research activities in this area, and it would be interesting to get back and discuss this in another forum later on. District heating could also be used in some cases to replace electricity and fuels. In Celsius, we have demonstrators where district heating is used for washing machines instead of electricity, and also to use district heating instead of oil in ferries. That has been tested in one ferry there with very good results. And so I hand over to the next speaker. Thank you.
Thank you very much, Anna. That was very, very interesting, great introduction. Does anybody in the audience have any questions for Anna? Anything you'd like her to clear up or expand upon? While I wait, sometimes it takes a couple minutes to write the questions properly. I have a couple questions for you. Just to what extent do you feel that the term fourth generation district heating is more of a marketing pitch or buzzword that is being used because it's fancy, or to what extent do you notice a real leap in technology and impact and efficiency between what we call third generation and fourth generation?
Well, I think so far it has been applied in some cases, not so many, but I think this is kind of a natural development because we have previously the first and the second generation, we have moved from high temperature systems with steam and moved towards water systems, even though with higher temperatures. So now the next step is to move further down in temperature level, and I think it is needed, at least in some cases, to move towards sustainability. Although it's not very detailed defined what it is, it can be seen in different ways.
Yeah, of course, the limit is not like a clear cut, but a transition. And in that sense, it leads to my second question is, can a city that is just starting on district energy systems, that is barely putting their first pipes down, can they go straight into what we call fourth generation or maybe even fifth generation? Or is it something that a network needs to gradually build up towards?
I think it might even be easier to do it from the start, that you design the systems for the lower temperatures from the beginning.
Great, thank you very much. So moving forward, Roberto Fedrizzi is coordinator for the Sustainable Heating and Cooling Systems Research Group at EURAC, which focuses on heating and cooling systems design, dynamic solutions, and laboratory tests as well. He also coordinates various European projects like Inspire, Build Heat, and FlexiNet, of course, as part of the International Energy Agency with Solar Heating and Cooling Task 56 on solar active envelope systems. Very fascinating. Roberto, what is the FlexiNet project and what are the solutions it will provide?
Okay, thank you. Thank you for this kind of introduction, and good morning, everybody. Let me understand if I took over the presentation. So I will move to the first slide. Do you see that, Emilia?
Yes, everything's running smoothly. Thank you.
Okay. Thanks. Again, what FlexiNet is about. As Anna said, FlexiNet is a research project funded by the European Commission, where we try to move further, a step further with respect to fourth generation networks, meaning that we go very low with temperature, and in addition to this, we go very low with the temperature of the network, 10 to 25 degrees, meaning that we try to really reduce to almost zero the energy losses, the thermal losses through the pipelines. But we also move forward in the sense that in addition to adding, say, wasted or renewable energy sources, as Anna said, that are available in specific points over the network, along the network, we also try to use the single customers as providers of thermal energy. And I will show you in a moment how we do that. Obviously, this is a good, say, idea, I think. However, this creates quite a lot of problems in terms of managing the energy, because the thermal energy, because actually the energy sources are not predictable anymore, and they are really much distributed over the network. As distributed, I would say, as the customers are. Therefore, what we are concentrating now in the research is on how to introduce thermal capacity, thermal storage capacity in the network design at centralized and decentralized level, how to develop control strategies to manage all these, so to say, unpredictable energy sources and sinks, and on the other hand, how to trade energy on the network. And again, I will talk to you in a moment about this. From the methodology method point of view, what we are doing now is on the one hand to try to understand how this network should be designed from the topological point of view, and on the other, how to connect different energy sources and sinks in substations that are easy enough as to be installed, say without too many complications, and on the other hand, they are standardized enough as to be understood and to be adopted by manufacturers, so to say. From the substation point of view, what we are studying is basically two typologies. On the one hand, what we call prosumer substations, which is basically what every single building, residential office, for example, would have in the technical room. And as we said, and as also Anna announced, basically, since we are working at very low temperature, 10 to 25, as I mentioned, we need some device to increase the temperature to the level which is needed by the building, by the heating system, not and domestic hot water preparation system. So basically, we have an heat pump, as you can see here, in the first sketch, which is increasing temperature from the network level to the needed one. On the other hand, this is another opportunity for the customer that can get also cooling on the same pipeline from the network. So by reversing the cycle of the heat pump, you can also provide cooling to the building, and you can recover the waste heat from the building into the network itself. And in this sense, the customer, again, as we said, is not a customer anymore, but is a prosumer, because it's producing and consuming thermal energy from and to the network. The other substation that we are studying is basically a production substation, and we are trying to understand which are combination of traditional fossil fueled solutions, devices that can be coupled with renewables and waste heat solutions to be used for conveniently, economically be used to integrate waste and to integrate thermal energy into the network. From the network point of view, here you see, for example, I reported in big an example of the prosumer substation, which, for example, could be what we are studying, could be made with a mixing valve in between the network and the heat pump, just to manage the temperature to the inlet of the heat pump. And then again, depending on the demands of the building, you might want to have only heating or heating and cooling, and domestic hot water, obviously. And then depending on this, you might have different configuration and sizing of the buffer tanks and the domestic hot water storage tanks. Again, this is a little more complicated compared to a third or fourth generation substation, but as you have basically one heat pump, but you also have storage tanks, one or two depending on the demands again. But this gives you also the opportunity to use the building as a source of thermal storage capacity, because basically by installing many small tanks into all your customers, into the utility company customers' technical rooms, then you might profit of their number by to build a huge storage capacity through the network. From the network point of view, what we are studying again is two configurations. On the one hand, one traditional configuration with only one with two pipes, one cold and one warmer, which is basically, as I said, a traditional solution, which could be good to transition or to move with the time from third generation into fourth generation and then into fifth generation as far as the demands of the buildings decrease. So to say, from actual standard to for example, net zero energy buildings or very low energy buildings, energy consumption buildings. But we are also looking into one pipe solutions. So again, nothing new, as there are already a few examples over Europe of low temperature district heating networks built in this way. And this is what we can quote as flawless district heating networks, because basically in this kind of solution there's no constant water flow through the pipelines, but the network can be the flow can be switched on and switched off based on the needs of the different buildings, and it can be also reversed based on the demands of the buildings and based on the specific local temperature levels into the at the different locations along the network. This again is absolutely not suitable for normal third and fourth generation solutions networks, but is again something that is really interesting in new fifth generation networks, because it allows to reduce as much as possible the electricity consumption on the main distribution pumps. As Anna said, and as I mentioned again, low temperature district heating networks are very interesting solution because you can reduce as much as possible thermal losses. You might somehow, depending on the topology of the network, reduce also quite a lot of electricity consumption for distribution. You obviously have a drawback, which is any single customer, final customer of the network, needs to have a heat pump installed in the technical room, and therefore basically the customer has to pay on the one hand electricity to run the heat pump. On the other hand, he has to use, or they have to use in general, they have to pay the thermal energy from the district heating. And the boundary here is that if you want to have customers, you cannot have an average cost of the energy delivered to the building which is higher than a reference heating price for a gas boiler, for example, or for a net-to-water heat pump. And so what we are basically concentrating on in this moment in the project is to look into this problem and to look at how energy, low temperature energy can be traded in these kind of networks. And to make an example, you see these three charts on the slide, which basically reports on what is the situation when you have a heat pump with a COP of 4, 5, and 6, providing energy to the final customer. And on the x-axis, you basically have the reference heating price that the customer pays with a gas boiler, for example. And the curves are referred to the electricity price that the final customer pays. So, for example, if you have, just to make it practical, if you look in the COP4 chart and you have a reference price for heating, which is in the range of 10 cents per kilowatt hour, and you can imagine that on average in Europe, people pays between 15 and 20 cents per kilowatt hour electricity. Then you basically see that on the y-axis that the energy utility company can sell the thermal energy out of the network at around 3 to 4 cents per kilowatt hour, which is very low compared to normal third and fourth generation networks prices. Obviously, the situation is not so bad all the time, as in this kind of networks, COPs, normal COPs that you can get is in the range, are in the range of 6 to 7. And therefore, again, if you look on the bottom right chart, you see that for a reference heating price of 10 cents, then you can get an usual electricity prices of 15-20 euro cents per kilowatt hour. The utility company can sell the thermal energy to at something like 5 to 6 euro cents per kilowatt hour. Again, to make a practical example, I took a COP of 5, what you see on the right side. And again, I try to imagine what is the margin, the net income the utility company can have based on the running cost to produce the thermal energy. So in this example, you start with 10 cents reference heating price. You cross the 15 euro cents per kilowatt hour electricity price line, and then you see that the utility company can sell the thermal energy at a maximum price of 5 euro cents per kilowatt hour. Imagine now that the annualized energy costs for the production of this thermal energy is in the range of 2 euro cents per kilowatt hour. Then the margin for the company, the net income for the utility company, is 3 euro cents per kilowatt hour. Again, these are very narrow margin for the utility company, and you see clearly that if you use traditional solutions like gas boilers to produce the thermal energy that you inject in the network, then the margins, the net incomes are very next to zero for the utility company. And again, this simple calculation that I made shows that these kind of networks is suitable only in cases in which the utility company can gather thermal energy at very low prices, again in the range of 1-2 cents per kilowatt hour, which is possible, for example, in case of waste incinerators, for example, which is the case here in Bolzano, for example. We are in the range of this kind of costs. It is possible, for example, in case of geothermal solutions, because in this case the investment cost is very high, but it can be split over an investment horizon of 30 to 50 years. I would say more in the range of 50 years, so it impacts somehow to a low extent to the running cost of for generating the thermal energy. Or again, it can be very much suited in case there are many sources of waste heat from chillers, refrigerators, for example, industrial processes where they use cooling towers, supermarkets, hospitals, for example, in summertime, or schools in case there is school time also in summer. Again, look looking into the just as a small example, looking into sources of waste heat, as I was mentioning this, and then I will close. I do not know, Emilia, if I'm too long. You stop me eventually.
Getting close, yes.
Okay, I have one slide only. So looking into waste heat sources, you can see in the chart what happens with the cooling. So if you have an air conditioner or a net water chiller for building for residential space cooling purposes, normally the cooling price for the reference cooling price for space cooling is in the range of 5 to 6, 7 euro cents per kilowatt hour net energy delivered to the building. Which again, if you cross this information with the cost of the electricity, 15 to 20 euro cents per kilowatt hour, then you see that the utility company can ask the customer to pay up to 3 euro cents per kilowatt hour, and in this case, the final customer would pay the same price as with a net water chiller or a normal air conditioner. Okay, therefore, again, a final customer could be a good source of waste heat in this case, because not only they get, if they pay the cooling, say they pay electricity, but they also pay thermal energy from the network or injected to the network, something like 1-2 cents, they would have a better situation compared to using conventional technologies. And again, the utility company would have the thermal energy available for a negative price. Okay, so customer pay to provide energy to the waste energy to the network. Again, there are what we are studying within FlexiNet, and with this I conclude, are a number of situations possible where the installation cost, the investment costs are on the shoulders of the customer or on the utility company. And obviously, if the customer holds the installation cost, for example, a final customer, residential customer, holds the installation cost for the entire substation, then it might be thought that the utility company doesn't ask any additional price for the energy injected into waste energy injected into the network. On the other hand, if the utility company pays for the substation, then we can imagine that the utility company can charge the final customer a cost per kilowatt hour, which is in the range of what we said before, 0 to 1 to 3 cents per kilowatt hour. From the larger providers' point of view, if we have larger providers in mind, for example, supermarkets, we can imagine again that the supermarket handles the investment cost, but then there must be some remuneration to the customer, to the prosumer, by the utility company, or on the other hand, the installation. Here there's an error. I inverted the two sentences. Or the utility company handles the investment, and then obviously the company can charge, the utility company can charge a bit the prosumer. So again, I don't want to spend much more time on this. I think I'm through. I just wanted to present a bit the kind of activities and thoughts we are going through in the project FlexiNet. The project is in the middle of the elaboration right now, so I cannot show you many results compared to this, but I invite you to follow us on the website and to ask questions to myself as anytime is needed.
Thank you. We actually
Thanks.
do have a couple questions. The first one is from Anders Fransson from Gothenburg Energy, and he's wondering if you could please explain the one-pipe solution a bit more. From where does the fluid or the water come from, as you don't get a return on the return pipe? So how would that function?
Yeah, basically, say it is not needed that you have a return pipe. It is a kind of a different point of view, obviously, compared to traditional networks, because basically you do not distribute warm water as you do in traditionally. Basically, the idea in this kind of networks, and there are a couple of examples only, I think, that I know. For example, in Zurich, the idea here, it is not to distribute warm water to the users. It is just to guarantee that the temperature all over the ring, in this case, as in this topology, is high enough as for the final consumers, for the heat pumps, so to say, to have a temperature level that is suitable for their operation. So as far as you guarantee by distributing waste heat or geothermal heat through the network back and forth, depending on where the temperature sources are located, as far as you guarantee that the temperature level all over the ring is high enough, then you are happy. So again, the idea is not anymore to bring warm water from point A to point B, is to guarantee an average, say, smooth temperature level all over the network. And again, it is not to maximize temperature difference between flow, return and flow pipe, but is to guarantee a smooth temperature, even temperature distribution.
Thank you. Anders, does that answer your question? As I'll let Anders answer. We also have a question from Marcus Wahlson from the City of Lund, who's wondering, for the building owner, what's the benefit of the system compared to local private geo-energy solutions? So I'm guessing if the buildings had their own heat pumps.
Yeah, the benefit is that basically you do not need to drill. So if you think to the situation in Sweden, for example, as we are speaking about Lund, if I've understood correctly, in Sweden, the building typology and the building settlement are kind of small settlement, apart from big cities, obviously, but in general, small buildings, single-family houses spread over large settlement. There are, however, situations like in Italy where you have the majority of the people living in large settlement and in multifamily houses. So you can imagine that drilling holes for geothermal probes and installing normal geothermal systems is not really easy to do at a widespread as a widespread solution, so to say. On the other hand, the advantage compared to normal geothermal systems is that in this case, on the network, you can not only integrate geothermal energy, which is usually in this kind of network used as a main backup system, but you can also integrate quite a lot of waste heat. For you to know, there are a few systems that are moving over Europe that are moving in this direction, and the idea is for them is in the next few years to reach waste heat levels in the range of 50, 70, 80%. So the geothermal energy which is available or which is used in the end is in the range of 10, 20, 30, 40% compared to waste heat. And this has the advantage, in addition, to conclude, that you can guarantee higher temperature levels in the network. Normally in a geothermal installation you can get temperatures around 0 degrees, so to say, a little below or a little above. In this case you can maintain temperatures in between 10 to 20, 30 degrees. And this again has quite a lot of advantages in terms of these thoughts that I showed. So when you have 20 degrees in the network, the COP of the heat pump is in the range of 6 easily.
Right. Thank you very much for that, those answers, and we will gladly, we can take it up again in case Anders or Marcus feel you would like more explanation, but given the time, I'd like to move forward. We still have two presenters with fascinating presentations. So moving to Jonas. Jonas Norrman is a managing partner at IMCG. He has over 15 years of business innovation and management experience with companies in the construction, energy, and ICT industries. Jonas has 20 years of international experience in research and innovation with several leading European research groups as a PhD in climatology. He's also on the board member of several companies whose areas of expertise range from business innovation and business intelligence, innovation by digitalization of services and products, attracting fundings for smart city businesses innovation, clean tech, and smart city utilities, including ICT. So Jonas, how are we bringing district energy systems to the digital world?
Thank you very much, Emilia. Yeah, that's a big question. I will give a short presentation today on our visions on how that can be done. And really, it's about connecting district heating to what is happening in the other parts of the society, and especially the buildings, of course, when it comes to the digital world. So my talk will focus on the digitalization in smart cities and the role of district heating and cooling companies with these new market conditions. And as we all know and heard previously, the fourth generation district heating and cooling system will be a part of the network society.
Before I continue, may I ask you to take over as a presenter?
Exactly.
So we can say thank you.
I was friendly assisted by Elena right now to do this. There we go. Just a second. So, and short about IMCG as a company, we work with innovation management and communication, as we see communication as a crucial part for innovation to take place in any system. And today I would like in my communication to present the future possibilities that are achievable, maybe not just in the future, but a very near future, as digitalization already takes place, as we all know, both among the customer segments, but also within the parallel systems such as water, sanitation, transport, and all the other parts. So integration between these systems and digital heating system is a way forward to bring district heating into the digital world. Our experience of digital transformation comes out of a number of interesting projects, and we have had the pleasure to work together with the Swedish district heating companies and especially Göteborg Energy during a number of years with a project called Green IT Homes. And my presentation will relate to this project, as my colleague Johan Emanuel previously gave a speech on the benefits from this and the result from this project. We also do strategic communication in Celsius, which keeps us updated on what is happening throughout Europe and what the visions are for district heating in Europe. And we recently assisted on putting together a successful winning proposal for another lighthouse project for Göteborg Energy called Fossil-Free Energy Districts. And one of the attendees just left the building to attend to these workshops. And maybe there will be more information about this very interesting project in a future webinar. And of course, me myself, I work as an expert on digital transformation in many different companies. As you heard, I work in the construction sector and also in the energy sector. And recently, we also focus on what is the next big thing. There's a bit of a name dropping here, but today we use cloud computing for many of the purposes within the network society. But next big thing will be edge computing. And I will come back to that. And also trust-based communication. We will see in not so far away, we will see a future where we don't need to have the passwords anymore. And I guess many of us are happy about that. Within all the projects that me and my colleagues at IMCG take place, we make sure that the overarching aim is always reduced environmental impact. And I would like to stress this specifically, because when it comes to digital transformation, there's a lot of discussion about cost cutting and new services and so. And it's hard to keep, sometimes hard to keep the environmental issues on the agenda. But I would like to bring back that we do this to make sure that this new smart city is energy efficient, uses renewable energy, have strongly reduced the climate impact, and also can make sure that we have a secure energy supply to the citizens of the city. And I guess many of you have heard the concept of Internet of Things and the network society before. IoT, as it usually is shortened. And of course, connectivity brings many new exciting opportunities, and we are, all of us, today well familiar with the smartphone and the mobile internet solutions that we use everywhere. But my speech today will actually bring up also the need of a new thinking about Internet of Things, and if cloud computing has been the big thing, what will happen with when we go for more distributed intelligence and work with horizontal IoT platforms instead. The distribution networks that we have been hearing about for heating, and also, you know, the distributing grids for electricity is well known physical structure within the city. But next big thing will be, of course, distribution networks for information. Who is owning those and who is running those platforms? And here there is an interesting opening for energy companies within, like a new business model. They can be a part of this new grid responsibility and also be involved in integrating solutions or between the different systems. Previous speech of my colleague Jonas Norrman started with presenting the starting point for a development project which we had together with Göteborg Energy, and starting like 5-6 years ago. And back then the situation was that the energy utilities, they had invested in what they called smart metering. And this was the sort of metering collecting system where we collected metering from energy for heating and energy for appliances, electricity, in all the buildings at all the customers in most parts of Sweden. The thing with this system that it was not very functional for many more things than just doing the metering and producing the invoicing basis. So in a workshop, we set up a number of suggested services with the next generation smart metering, which now when you look in the back mirror, you can say this is really the first generation of an IoT platform. And as you see to the right, there is a number of energy management services and utility operation possibilities that were a request when we started the project. And we also had a structure with a two-way communication, high-speed two-way communication, to be able to also use control functionalities. The Green IT Home structure ended up in what is today is a well-known cloud server connectivity solution, where we have hardware in buildings, connectivity solutions over mobile broadband, and a big server handling the connectivity and handling the information over to a number of different applications. It could be web applications in a computer, or it could be mobile applications in a smartphone. And all was very successful, and we came forward not only presenting the technical solution, but also the business solution and the new services for the client and for the utility operations. So this is up and running and accessible if you would like to have it a try. And if you would like to hear more about it, you can also listen in to the previous webinar presentation by my colleague. Was it in December, November? December. But what we've been looking at since then is really the next generation of IoT platforms, and building what we did with Green IT Homes, the cloud-centric vertical solution is a neat one-to-one, end-to-end solution, and it, as they say, a turnkey solution. The district utility can order this and have a perfect functionality. However, if you start to integrate things within the city, you realize pretty fast that the cloud-centric solutions, for example, for energy heating, for electricity, or for water, or for electric cars or other things, they have their own vertical solutions, and they are very complicated to build integrated solutions, so-called horizontal solutions. And on top of that, over the years, we also have had a lot of discussion regarding the security of the systems. Today, most of the vertical solutions are password security, while with a horizontal solution and a next generation IoT solution, you can have what they call a cryptographic security. And talking about secure energy systems, this is maybe one of the most important issues when it comes to a connected energy system. Can there be hostile takeovers of an energy system to stop energy production? But with a cryptographic solution and edge computing, which is where you have distributed the intelligence from the cloud down to the hardware within the buildings, you can have a much more secure system. You have, with a new system, you have the IoT hardware and sensors and displays and otherwhere located in the building, investments made by the building owners themselves. You have a common marketplace for all the information available, which can be run by an energy utility or any other citizen representative body. And in this marketplace, you can find all the information from all the buildings available. You have sensors for water consumption, electricity consumption, or heat, or outdoor temperature. Every sensor you can think of. You can also offer control functionalities for service and support. You can have top load or short-term storage. But you can also access communications displays. That could be displays within the buildings, or it could be displays within the flats, or even in mobile applications. And all this is securely accessible through a marketplace, and there is a business model available for this as well. So there is if you would like to access a certain number of sensors, for example, water consumption, there is already a fee for this, and a payment model in place as well. And this is demonstrated throughout Europe in other projects, and we think it could be very interesting to test this as a part of the next step for Celsius as well. So what is the benefits for the energy utility with these new possibilities? Well, of course, when it comes to building a digital system together with your clients, it's always the interest of who takes the investment costs. In this new system, you can share the investment cost between the building owners and the energy utilities. And as you don't need any bigger cloud server platform, you don't have the cost of establishing and running that platform either. You can use the possibility to open up for a new business model as well. We know that energy companies are already, as we heard, for the future possibilities as well when it comes to district heating. You are a specialist in sharing economy. District heating is in the future more and more excess heat from one part to heat to another part, who's in need for heat and for heating and hot water. Electricity, we know for many years now that owning the grid is all about distributing from producers to consumers. And what we see building up fast in international is also that in similar types of information grids will be a part of the future city. And we think that the energy utility has a nice position to actually grasp those opportunities. To do this, you need to realize that information is a commodity, and it has been complicated until now to offer this commodity, as it has been no business models or payment models in place. But with the next generation of IoT protocols, this will be both easy to implement and fully secure to implement. And the energy utilities themselves can use not just the new business, but also use the new access to sensors and control units within the buildings to further increase the deliverable of the traditional services, such as heating or cooling or electricity. In this slide, we have an overview of the business requests that we had from the very first start of Green IT Homes, and still these are valid. We started out building a cloud-centric model to deliver these energy management services. Today we build a horizontal solution, a edge computing oriented service, but the same functionality is still available, but on a more investment friendly way. And as the benefits from the preliminary tests of the Green IT Home system show that there is a possibility to do the profitable transformation of district heating and cooling into the digital world, including a reduced environmental impact. We say that it was true before, and it's even more true today. When it comes to energy efficiency, the reduced climate impact, but also today with a much more secure energy supply available. I think that was my last slide. Yes, then I off the screen. Thank you.
Great, thank you very much for this presentation. I'm wondering first is if any of the other presenters or anybody in the audience has any questions for Jonas regarding his presentation. As we wait for you to type in, or the presenters, please feel free to just mute your microphone and ask directly. I have a question for you. The way you describe things, or everything you've described today, feels very much futuristic and almost sort of the systems of the future, but they're a reality today. So my question to you is, how do you think district energy systems will be managed 15 years from today?
That's a good question. With the integrated solutions, and I think it's important that if the energy utility will continue to manage the grid system within the cities, you need to be involved in also development of these information platforms. as with the connected buildings, the owners of the building management system will have much more possibilities to operate further out in the energy grid system as well. And I'm not sure in the 15-year future whether there will be any utility running the grid, or there will be a group of building owners running the grid for a large neighborhood. That's they are ahead of the connectivity solutions, and can also operate the system within the building today and with the future also together among a number of building within a building block.
That's interesting. So it would be sort of the Uberization, as we call it, of energy networks.
Exactly.
Great. Well, thank you very much for that presentation and answers. We can absolutely come back to this at the discussion, at the end discussion. But I would like to introduce Kristian. Kristian Honoré is an energy planner at Greater Copenhagen Utility Company. Kristian is the project manager for the district heating activities at the Energy Lab Nordhavn project. His work currently focuses on the integration of thermal, electrical, and transportation infrastructure. So it's merging of the different infrastructure. Kristian, would you like to tell us a bit more about the work you do?
Yes, of course I would like to do that, Emilia, and thank you for the introduction and the very exciting webinar so far. My name is Kristian Honoré and I'm an energy planner at HOFOR. And just a few words about HOFOR being the multi-utility company for Greater Copenhagen. The company is fully owned by the municipality. We are a non-profit company and our main services or utilities are district heating. We have around 600,000 customers. We also provide water, town gas, district cooling, and wastewater services. Our guiding star is, so to say, to provide renewable, safe, and affordable services to Copenhagen and its inhabitants. Copenhagen has a target of becoming the first CO2 neutral capital in the world by 2025. This is a very ambitious target, and to get there, we are among other also looking into activities within the fourth generation district heating concept. Among other, low temperature district heating. In our concept, we look at supply temperatures of around 70 degrees. Remember, Copenhagen is an old city. Most of the buildings are close to 100 years old. It's difficult for them to heat up their apartments with lower temperatures than 90 degrees during winter time. So even the 70 degrees as a supply temperature is limited to new areas of Copenhagen. The city is developing rapidly these years, so many of these new buildings easily match the 70-degree supply temperature. Basically, as earlier heard, the limit in supply temperature comes down to safe and reliable domestic hot water. Furthermore, we're looking into various surplus heat sources. We have around 10 to 15 major customers who have approached us because they are interested in supplying surplus heat to the district heating network. In Copenhagen, we do not have much heavy industry, so the companies contacting us are typically from within the pharma industry or the supermarkets having excess heat from their cooling equipment. So here we're looking into the business case for HOFOR and the different companies. We have to look at how much energy, what temperatures, what is the load profile throughout the year, because as you know, heating has a different value throughout the year. Also, we're looking into what we call flexible district heating, or as you call it in Gothenburg, short-term storage. Which possibilities do we have in interrupting, reducing or charging our networks, our buildings, our apartments? We are looking into equipping specific buildings with controllers that allow us to reduce the district heating supply in peak periods. We are looking into doing the same for larger areas of Copenhagen via the group centralized district heating substations. Also looking into the potential of the district heating network. What temperatures, what pressures can we optimize here in peak load periods or off-peak load periods? Furthermore, to get closer to the target of becoming CO2 neutral, we have to focus on alternative production methods. Some of them have been mentioned already, and they all possess a huge future potential. Heat pumps, electric boilers utilizing excess electricity coming from the wind production, geothermal wells, where we also have a smaller geothermal plant in Copenhagen and are looking into further areas for developing these solutions. However, these three or these alternative production methods still represent fairly low amounts of energy and are quite expensive and risky comparing to the well-known production methods we utilize at our CHP plants today. So further CO2 reductions are definitely needed. And some of the tools that we're looking into are conversion of biomass at our existing and new heat and CHP plants and heat-only boilers. In Copenhagen, we have two main CHP plants, partly on biomass, and as of 2020, we will have a new big one only running on biomass. Also, the conversion of peak load boilers from fossil fuels into funny fuels or biofuels is something we are looking at constantly. Again, we're looking at the geothermal plants, the heat pumps, electric boilers. They possess a huge future potential, but here now they are risky and expensive. Also, we have, of course, to focus on our customers and the opportunities in their apartments, in their buildings. So here we provide energy saving services. We have a web-based tool called FlexiNet, which represents an easy way for the customer to have guidance from HOFOR on energy saving measures. We're looking into optimizing temperatures throughout the year to minimize heat losses without compromising the comfort level at the customer side. In the old part of Copenhagen, we have still a fairly large part of the network running on steam, high temperature or high pressure steam, and this is being converted during these years, and we expect to finalize this project by the end of 2021. This will definitely provide huge CO2 reductions and also minimize heat losses from our future network downtown Copenhagen. To the right, I have listed the goals for HOFOR district heating in becoming CO2 neutral. By 2015, we have calculated that the district heating supply has been 51% CO2 neutral. By 2020, it has to be 80%, and as earlier mentioned, already in 2025, 100% CO2 neutral. Based on that, we have developed this guideline or planned schedule for becoming CO2 neutral on our district heating supplies. And as you can see, we have an expected dark green, dark blue line, and we have a realized lighter green line and a light blue line for our target. Not so many figures are filled in yet, because most of the figures are the planned targets that we have for becoming CO2 neutral. But we have already, towards the municipalities, shaken hands on the 2020 target being 80% CO2 neutral and the 2025 target becoming fully CO2 neutral. To get there, we have initiated, as I have earlier mentioned, various projects and activities, and honestly, most of them represent changes in our production. So in 2016 and 17, you will see some of the CHP plants converting into biomass fuels. You will see a new, more efficient waste incineration plant coming into operation 2019. An old peak load boiler will be converted from oil to gas in 2020. A very large CHP plant running on wood chips will go into operation. The steam conversion is terminated. And then we are so far ahead that we are still not clear on which activities to invest in to get from 80% to 100%. But the remaining 20% CO2 stems from still fossil fuel peak load boilers, typically running during winter time, as well as the fossil part of the waste, which is firing or fueling our waste incineration plants. So there's still a lot to do. Many clever people and companies are working on this and assisting us in developing new solutions, new products, new tools, web-based or more practical in the plants themselves. Definitely the target will be to become CO2 neutral by 2025. And Emilia, I don't know how the time limit looks. Otherwise, I can continue with some more detailed introduction to the Energy Lab Nordhavn project, or we can stop the presentation here with the overall ambitions for HOFOR.
Would you be able to give a brief presentation, not a detailed presentation, on the Energy Lab, and then so we can have a couple minutes? We may run over 12 o'clock, it depends on the presenters, but maybe a brief introduction on the Energy Lab Nordham, so we can have an idea.
For sure.
And then we can open up the discussion. Thanks.
Energy Lab Nordhavn is a large Danish-funded research and development program focusing on integrated energy services. The main target of the project is to integrate thermal infrastructures with electric infrastructures and transportation. The project is led by the Danish Technical University, and there are 12 additional partners coming from the utility side and the industry side. And one of the interesting projects that we are looking into is how to integrate and operate heat pumps at large scale in an integrated energy system. I think that's more or less it for now, Emilia.
Great, thank you. And also for all of our listeners, the slides will be available on the wiki shortly after, so you can look more in detail, and we can of course always use the LinkedIn discussion group, but we'll get to that in a minute. Are there any questions from the other presenters or from the public for Kristian? While you write your questions or think about them, I would like to ask you, what are your challenges in moving towards this fourth generation district heating and CO2 neutral network? What are the main challenges that you're facing?
Our main challenges is that we always have to balance being the safe and affordable utility company providing competitive district heating to our customers. Because for sure we can realize becoming renewable, but we always have to consider what will the cost for that be, and does it make sense for the municipality and our customers, being the inhabitants of Copenhagen.
Thank you. I have a question actually for all of the presenters. Now we've seen these amazing technologies being developed, and it almost feels like we're making leaps and bounds. Two questions. First, are there technologies that are in place today that you've seen that you never would have thought you'd see in your lifetime, that really sort of are surprising you? You'd think they would have been developed in 20, 30, 40, 50 years from now, but that they're reality today? And my second question would be, do you believe one day we'll be able to get rid of a gas network in cities that will become so energy efficient and be able to use waste heat to such a degree that we'll be able to phase out gas distribution networks? Anybody? Anna, in the research you've done, is there any technology you've tested that you thought would not be possible, but it is a reality?
It's a difficult question. Not that I really think of at the moment. I think it's more about how the technology is applied and combinations. And I think these things with digitalization and communication, this is a pretty new thing to me. It's interesting.
Thank you. And we do have a question from Anders. So thank you, Anders, for all your question and participation. This question is directed towards Kristian. What is the budget for reaching the goal of being CO2 neutral by 2025 in Copenhagen? I'm guessing, yeah, there's a lot of investment being made by the city.
Yeah, that's a very good question, and I have no clear answer on that.
Thank you. I guess these budgets are tricky depending on how the investments evolve. Next, second question for you, Kristian. How do you ensure that the biomass you'll be using in the CPH, is CO2 neutral?
Yeah, that's also another good question. We have a group of people looking into securing that the biomass we will use in our CHP plants is CO neutral and renewable and produced in a sensible way. So we will have and have already visited several countries and suppliers to secure that on their premises and on their production site, everything is running so that we can have a certificate guaranteeing that the biomass that we buy is renewable and CO neutral.
Thank you. So you do have a system of certificates being put in place.
We are setting it up because it's new. It's not something existing. So we are doing this in cooperation with other companies and suppliers who have the same challenge as we have.
Great. I see that Lennart is writing a message. Thank you. So as he finishes writing his question, it's very fascinating going back on your presentation, Kristian, on sort of the way you're using these new urban waste heat sources. It'd almost be interesting to do a webinar just on that. I can imagine the sources are almost limitless as soon as you start looking into it. And how much would you say of these specifically urban heat sources, how much do you say we know them pretty well as we know sort of all the industrial waste heat sources, and to what point do you say that there are these new possibilities being discovered in quotation marks as you develop this fourth generation system, if that makes sense?
Yeah, I think it very much depends on your city or neighborhood. Copenhagen does not have any heavy industry like Gothenburg. So the heat sources we will be looking into from our customers will be within pharma, within supermarkets, and they are not capable of providing high temperature supplies to the district heating network. But for a fourth generation district heating system, they will definitely be able to supply sufficient temperatures, and if not, we can boost with a very efficient heat pump to secure again the domestic hot water being safe and reliable, which is today the limit for going down in temperature. Otherwise, we have many activities looking into the potential for geothermal, for instance. So far, the focus, at least in Denmark, has been on more centralized, larger plants. But actually, we have now had the project looking into the second generation of these geothermal plants, simply to reduce investments and risks. And they target smaller, decentralized systems of around 10 megawatt each, which could be the new scenario for geothermal setup in Copenhagen for the future.
Thank you. So Lennart Hjalmarsson from Gothenburg Energy is also asking what heat storage solution is implanted to be used to become fossil free. Are you using any thermal energy storage solutions?
Yeah, we have already 3 very large centralized heat storages, each being 24,000 cubic meters of hot water. They are used for peak load balancing throughout the day. But we also have a project looking into if we have sufficient storages. Most probably we have not, but then we have to find out what would the future need be, and quite simply, where can we place these large heat storages? Are they to be under pressure or not under pressure, and at what temperatures? Many possibilities, but also many challenges when you live in a very dense city like Copenhagen.
Yeah, thank you. Unfortunately, we've run out of time, so I would like to thank all of you for taking the time and participating in this fascinating discussion. Personally, I'm very curious to see how district energy systems will look like by the time the four of you and your projects, by the time you retire, we may actually manage to save our planet. Thank you all of us for participating and joining us.